so hopefully you guys are seeing my screen. If for any reason you can't, just let me know, pop a message up in the chat window, and I'll get that fixed. But let's go ahead and jump right in. Like I said, this is the Blockchain Training Alliance's webinar on private versus public blockchain. So we're going to talk a little bit this morning about what blockchain is. Got a message in chat that Jeff isn't hearing anyone. Are you guys all able to hear me? Just put a yes, no in the chat window. Let me know. Okay, we're getting a lot of yeses there. So, Jeff, maybe try dialing back in or reconnecting. Seems like other folks are able to hear okay. So we're going to talk a lot this morning about public versus private blockchains. We're going to start out real quick and just talk about what blockchain is. If you're new to this space or that's a new term, we'll define what that is. And we're going to talk about private blockchains, Ethereum in particular, and how it compares and contrasts to Hyperledger. Then we're going to dive in and talk about blockchain in the enterprise, blockchain for business. There's a lot of focus right now on blockchain in the public sector, blockchain in B2C uses, but there's really some cool stuff happening in the B2B world, enterprises adopting blockchain into their business networks, and I think that's going to be a really big growth area, and it's one we're very excited about. So let's go ahead and dive in. Like I said, my name is Chris Bennett. I'm an instructor and course developer with the Blockchain Training Alliance. So I teach a number of courses with BTA. I've authored and put together the materials for our blockchain architecture course. I also teach our blockchain developer courses. We offer training and certification around blockchain, so blockchain architecture, blockchain development, blockchain cybersecurity are some of our most popular offerings. We also offer classes on blockchain and IoT solutions architecture, and we're working on a number of different courses all in the blockchain area. So really exciting stuff that we're doing. I also spend the other half of my time doing solutions architecture consulting, working with organizations to help identify good use cases for blockchain and help them design and develop and make those solutions a reality. Really goes hand in hand with the instruction. I like to use the analogy that it's a lot like baseball. You could sit in baseball class and learn everything about baseball and read every book ever written about baseball. And that's kind of what we do at Blockchain Training Alliance. But that very first time you step up to the plate to take a swing at the ball, it's really nice to have a coach there. And so we provide a lot of design and architecture consulting as well. So any questions you guys have or follow up from this, please reach out. I'd love to continue this discussion with anyone who might be interested in how blockchain might be able to be integrated into their enterprise. So let's start off. If you've never heard of blockchain, or you're new to blockchain, or you think maybe that's just a synonym for Bitcoin, let's go ahead and define that. Let's talk about what blockchain is. And as you start to get involved in blockchain, one of the first terms that you're going to come across is decentralized ledger or distributed ledger. You'll sometimes see blockchain abbreviated as DLT, decentralized or distributed ledger technology. And if you really want to understand what a decentralized ledger is, well, we don't have to talk hypothetically about it. We can actually go back in history. And we can go back in time 3,000 years to the year 1000 BC, and we can look at an instance, the earliest and the first and only known instances of people using a decentralized ledger. And all this happened 3,000 years ago on a very small island called Yap Island in what is modern-day Micronesia. And the Yapese people had a very interesting economy. They had money just like we do. They used limestone coins that they called ray stones. The only interesting thing about these ray stones is they were gigantic. You can see one in the picture on this slide. These ray stones could be well over 12 feet tall and weigh in excess of 8,000 pounds. So they had a form of money that it wasn't practical or pragmatic to exchange physically. And so the Yapese people had to come up with a way to be able to conduct trade and commerce without physically exchanging money. And the way that they did that, hang on, I'm just going to go back and mute everyone. Guys, if you could just keep yourself muted, that just helps with any background noise or interference. Really, really appreciate that. So we're getting a little feedback from people. Let me just go through, make sure everyone's muted. All right. Thanks, guys. And again, if you have any questions, just pop them in the chat window. We'll, I'll again ask just everyone to stay muted just so we minimize any feedback and make sure everyone can hear the presentation, okay? Well, what the Yappies did in order to be able to exchange and trade and conduct commerce is instead of physically exchanging these Raystones, these gigantic coins, they all just kept a mental ledger. They all kept track in their head of who owned which coin. And so they had a really simple system. They would place these coins in different strategic areas around the island. So they might have one on the beach and one in the center of town and one over by the forest, one at the base of the mountain. And they would just keep track in their head. They would keep a mental ledger, all of them collectively, of who owned which coin. And so if two people wanted to trade, let's say we have Alice and Bob, because as you guys know, in any example in finance, economics, or physics, your participants are always Alice and Bob. So let's say we have Alice and Bob, and they want to conduct a trade. Alice has agreed to give Bob half of her cattle in exchange for Bob's coin on the beach. And so the way this worked was very simple. Alice and Bob would just stand up before the tribe and they would announce this transaction. And if the tribe all agreed that was a fair and valid transaction, then they would all update the ledger in their head. And they would just know from that point on that the coin by the beach is now owned by Alice, not by Bob, and Alice retains the value of that coin and it's hers until she decides to spend it somewhere else on some other thing. And then ownership transfers again. And this is what's known as a decentralized or distributed ledger, and we call it that because all the participants are keeping a copy of the ledger in their head. And it's a little bit different than how we do things today. If we were to try a system like this today, most likely what we would do is we would appoint a single person to keep track of that ledger. We might call that person a bank or a banker. And certainly this would be more efficient because we could offload all this work on just one single person. So the rest of us would be free to go and perform other tasks, other duties. But we would lose a lot of advantages of a decentralized ledger. So by everyone keeping their own copy of the ledger, not just offloading this to one single person, we get a lot of security. If I want to try and change the record in the ledger, well, I can't just bribe one person like I could if we had a single banker or a single person keeping track of ownership of these coins. I would have to convince 51% or more of the tribe to go along with my bribe to change the record in the ledger. So it's a lot harder to tamper with the records or the data in that ledger. And it gives us a great deal of security. It also provides a lot of redundancy and fault tolerance. If we had just one person on Yap Island who was tracking the ownership of these coins, and that person got sick or they were busy, they were out hunting, they couldn't participate in trade for a day or two, well, our economy would come to a stop. In this decentralized model, we can have folks come online, go offline. As long as we have two or more of us present to record these transactions, it's no problem. We can just get everyone caught up when they come back. And without really meaning to, this decentralized ledger model that the Yappies invented ended up recreating a lot of the major services that a bank provides, but did this almost 2,500 years before the rise of modern banking in Italy. So this decentralized ledger, just by its very nature, is able to take deposits and issue credits, big function of a bank. It's able to act as a trust broker in relationships or trades where you and I might not know each other well enough to trust each other. So You can think about this. Maybe you want to buy my used car, and we agree on a price. We strike a deal, and then you ask me, hey, can I write you a private check? Well, I might be a little hesitant. We don't know each other very well, and I might say, can you go to the bank and get a cashier's check? What we've done is we've introduced a trust broker into our relationship because you and I can't trust each other well enough, but we can both trust the bank well enough. Well, with this decentralized ledger, all I really have to do is trust the integrity of the data on the ledger. And we don't need to bring a third party in. The ledger itself acts like a trust broker. And then they also decoupled possession and ownership. Right? I don't have to physically drag these coins around in order to own the value behind them. And so when you think about blockchain, you can just think of this very simple scenario, what happened on Yap Island. And all blockchain is it's a modern computerized implementation of this very ancient decentralized ledger technology. So blockchain provides a lot of benefits, serves a lot of great use cases. It provides record-keeping functions. At the very heart of it, I like to talk about in class that blockchain is just like a sheet of paper. It's like a sheet of paper in that the paper doesn't care what kind of data you can write on it. You can write any and every kind of data onto a piece of paper. Might have my very first line on this paper might be banking and financial information, and the second line may contain the opening notes to one of Beethoven's symphonies. So I can mix and match all kinds of data on this paper. That's essentially what blockchain gives us. If you're coming at blockchain from a finance or accounting point of view, you may have also heard of blockchain referred to as triple entry accounting. Basically, this is this idea that we're all used to double entry. We've probably all learned about that in high school or college at some point. This idea that when we keep a ledger, we're tracking both debits and credits, so we can tell the story of the transaction from the point of view of all participants involved. Well, blockchain gives us what's known as triple entry accounting. We still have our debits and our credits. But we also have this third link, this immutable, unbreakable link back to every previous transaction. So if anyone tries to go and change any previous transaction in the ledger, it's very obvious that they've tried to do that. This gives us a high degree of data immutability. I'm going to stop presenting just for a sec so I can mute everyone. Just one more request, guys. If you can just please keep yourself muted. We do get a lot of feedback. If you guys aren't, that would be really great. So we get a lot of data immutability, this idea that I can't easily go back and change any of the data, alter the record, because this ledger is duplicated across so many different nodes or different participants. We get a high degree of redundancy and fault tolerance. Just like on the island, if some of us go off and go on a hunting trip, we're not able to help keep up with the ledger, that's okay. We'll just get synced up when we come back online. So high degree of fault tolerance there. Provides decentralization, so we're not reliant on centralized entities to come in. We gave the example about the bank acting as a trust broker in relationships. And it creates a shared infrastructure. So different organizations can participate in transaction and trade with no one organization having claim to the infrastructure that supports it. And then finally, blockchain to some degree is always a trade-off of performance for security. So if you're analyzing use cases in your business and your organization, any use cases where security trumps performance, blockchain may be a really good fit. Use cases where performance is the #1 goal, and that's more important than security, blockchain might not be the right fit there. So a lot of folks get into blockchain from Bitcoin. I like to joke that Bitcoin is the gateway drug to blockchain. Bitcoin is a cryptocurrency, if you're not familiar with it. It was launched just about 10 years ago. It's just a digital form of money. Essentially, it is nothing but a ledger. It's nothing but blockchain, just tracking folks, trading digital wealth back and forth. And this is the entry point for a lot of people into blockchain. In fact, if you're talking to folks new to the space, there's a common misconception that blockchain is just another word for Bitcoin. But really, Bitcoin is to blockchain what email is to the internet. If you think back to the early days of the internet, email was really the first consumer-grade application that was deployed at scale on this new technological platform. That's exactly what Bitcoin is to blockchain. It's this first consumer-grade application that people are adopting at scale. But just like 25, 30 years after the rise of .com and the internet and email, we look back and we go, wow, email is a critical part of our life. I couldn't imagine living without it. But when I look at all the things that we've done on the internet, email is probably the most pedestrian and boring of them all. I honestly think we're going to look back in 25 or 30 years and talk the same way about blockchain. About Bitcoin. It's something indispensable. It's an incredible tool. It was very transformational. And given all the things that we've done on the platform since then, it's also pretty boring. And then finally, Bitcoin is just a currency. It has a very, very limited ability to do anything smart, for you to develop any logic in it. There is a programming or scripting language behind Bitcoin called Bitcoin script, but it's very limited. If you come from a development background, just understand that Bitcoin script doesn't let you perform any loops or iterations. And if you're a developer, you probably realize how limiting that is in a development language. There's another misconception in blockchain that, hey, isn't blockchain just a shared database? Well, kind of, sort of, but not really. You can think of it that way as long as you understand a few caveats, a few gotchas. When we talk about databases, especially traditional relational databases, if you come from a background working with databases, you're familiar with CRUD, create, read, update, and delete, the 4 functions of a database. What makes blockchain a little bit different is it's what's known as an append-only ledger. In other words, it's exactly like a database, except you have absolutely no update or delete function. All you can do with a blockchain is read or add another record, append another record. So it's a little bit different in a database in that sense, that there is no update or delete. All the information that you put on a blockchain is permanent, and all you can ever do if you want to change that data is just to append another record indicating that that data has been updated and the new value should be XYZ. And so that gives us, on blockchain, a full history of all the data points on blockchain rather than just a current snapshot like we get with the database. There's several different types of blockchain. As you start to get into blockchain, you'll probably hear a lot of discussion back and forth about public versus private blockchain. And oftentimes what gets left out of the discussion is open versus closed. So when people talk about a public blockchain, they tend to be talking about a public open blockchain. When they talk about a private blockchain, they tend to be talking about something private and closed. But it's important to consider both distinctions, not just who can write data to the blockchain, but who can read that data. And this gets into a very nuanced discussion of permissionless platforms versus permissioned platforms. In other words, do I want to treat all my users equally or not? In a permissionless environment, because by definition, I'm not applying permissions to anybody, I'm just treating everyone equal. In a permissioned blockchain, I'm giving some folks some roles, abilities, and access that I don't give to others. And so I'm not treating all users equally. And it's important to consider this when you look at the types of solutions that folks are looking at building on blockchain. These are not absolutes, but up in the top right, public open solutions. You can see I've got the Ethereum logo there. These tend to be where we see public permissionless platforms like Ethereum being used, versus what we see down at the bottom left, private and closed. where those tend to be more Hyperledger or private blockchains. The areas we see in the middle, the public and closed, private and open, are kind of either or. You may want to use Hyperledger for some of the built-in permissioning, or you might want to just build some of your own permissioning and identity management in something like Ethereum. But this kind of gives you an idea of some of the different use cases, very different from one another. Things that are public and open might be the cryptocurrencies that we know, or some kind of video game network where players can track their achievement. We're treating everyone equally. Everyone can see all the data. Anyone can contribute data. Versus things that might be very private, closed, lockdown solutions for the military and law enforcement, or various construction projects where only the general and subcontractors need to be able to write or read any data, and then kind of anything and everything in between. And so I like to talk about, when I'm explaining blockchain to people, this onion model of transactions, because it really helps you understand the types of data that can be recorded on blockchain and get us past a lot of the misconception that blockchain is just Bitcoin. So I call this the onion model, because we're going to start at something very familiar, and we're going to peel away layers until we get to the heart of what blockchain actually is. So the very outer layer of this onion is what we're all familiar with. It's what we see with cryptocurrency, with someone paying someone else in Bitcoin. This is two or more parties coming together and announcing an exchange of monetary value. So I'm going to pay my friend Lucy $100 worth of Bitcoin because I lost a bet with her. This is what we all know and think of when we think of blockchain and cryptocurrency. Again, two or more parties, and they're announcing some kind of exchange of monetary value. Well, if we take that outer layer and we peel it away, let's take the idea of monetary exchange out of the picture, and we still have two or more parties coming together and announcing some kind of transaction, but that transaction doesn't involve the exchange of any kind of monetary value. So we might use blockchain to track medical information. And I may go to my doctor, get my annual checkup, physical. My doctor might say, Chris, I want to put you on a new prescription for XYZ. And let's go ahead and let's update your blockchain medical record to reflect that. That's still two or more parties, right? I should not be able to update my medical record without a licensed physician being involved. And I surely don't want a doctor going and updating my medical record without my consent. So it's still very important that we have two or more parties involved. But there's no exchange of monetary value. We're simply just updating a data point. And if that makes sense, then we can peel away the final layer of this onion and get to the real heart of blockchain, which is just a single party standing up and announcing an important event. So this may be blockchain in the context of voting, or blockchain in the context of supply chain management. A supplier just saying, hey, I delivered some parts to this factory. Or a voter saying, hey, I voted for Alice in the mayoral election. So we just have one single party announcing an important event. We don't require two or more parties, and we don't require any kind of exchange of monetary value. And if you get that, then we'll talk about this a little more in a second, but if you get that blockchain can just be a single party announcing that something important has happened, when we start to talk about smart contracts and how you can program logic into the blockchain, another way you can think about blockchain is as a workflow or a business process automation or management solution. If I have the ability to mark important events, and then define rules for how those events are processed and handled, well, I'm right back to the definition of a workflow or a BPM solution, but one that can potentially work with money or real world value. So let's talk about Ethereum. Like I said, we're going to compare and contrast Ethereum and Hyperledger. A lot of folks, when they get into blockchain, think that these two platforms are competitors to one another. Really, they are very, very different animals, and they can actually complement each other very, very well. But if you're unfamiliar with Ethereum, Ethereum is an open source project It's managed by a group called the Ethereum Foundation. One of the biggest backers, corporate donors to the Ethereum Foundation is Microsoft. Something Microsoft doesn't talk a whole lot about. I'm not sure why, but they're very deeply involved in Ethereum. They're certainly not the only corporate backer, but they're one of the bigger names involved. Ethereum is just coming up on its 3rd birthday. Went live in July 2015. So still a very, very new technology. And Ethereum was really created as a reaction to some of the shortcomings in Bitcoin. Like I mentioned earlier, Bitcoin had a very, very limited development language called Bitcoin script, which didn't allow things like loops and iterations. The Ethereum Foundation saw that as a limitation and thought, boy, if we really want people to build cool solutions using this blockchain technology, we have to really give them a complete programming and development language they can use to do this. So Ethereum supports this through the development of what are called smart contracts. Ethereum supports several different languages, development languages. Solidity is the most popular one. These are all known, what are known as Turing complete languages. So again, if you come from a development background, that might mean something to you. If not, just know that Turing complete means that these languages are on par with any modern programming language. They can do anything that a language like C++, JavaScript, Visual Basic, etc. can do. Smart contracts give us the ability to write computer code to define rules and processes that get invoked when a certain type of transaction occurs. And so they give us a way to actually make programmable money or smart money, or to automate different processes where blockchain is the source of record. And Ethereum does this through an abstraction called the Ethereum virtual machine. Essentially what that means is if you are developing an Ethereum solution, or you are the end user of an Ethereum solution, there's nothing in that experience that's going to tell you anything is happening on blockchain. It really feels like a typical client-server experience. The fact that all this is happening on a massive, globally distributed peer-to-peer network is abstracted away from you. And Ethereum is what's known as a public blockchain. It means that anyone can use it, anyone can write data to the blockchain, anyone can read data from the blockchain, and any data that's stored on the Ethereum blockchain is fully transparent. So it's also what we call a permissionless blockchain because Ethereum is anonymous. We don't track individual user identity, or at least that's not something that Ethereum supports by default. If you want to support identity management, that's something you need to build into your Ethereum-based solutions. So the fact that it's anonymous and we don't know who users are also makes it permissionless, right? If I don't know who you are, it's very difficult to talk about what you are allowed to and not allowed to do. So that's what gives Ethereum its full transparency and its public state. Ethereum has a very large ecosystem behind it, so if you're just getting into blockchain and you want to learn about smart contract development and get your feet wet, Ethereum is a great place to start. See, I think I might have lost my screen sharing. Try that again. Apologies for that. So if you want to go learn to write smart contracts, Ethereum is a great place to start because you will find more tutorials, more how-tos, more instructional videos, more support, more Reddit threads, etc. about Ethereum and Ethereum smart contract development than just about any other platform. So it's a great place to start. As I mentioned, Ethereum has many different development languages. A couple of the most popular are Solidity and Viper. So Solidity, if you're familiar with C derivative languages, if you do any development in JavaScript or C#, it's going to be very, very easy for you to learn Solidity. If you come from the Python side of the fence, they also have a language called Viper, which uses a Python-style syntax. One of Ethereum's big contributions is a built-in coin or token model. So if you want to create your own coin or token, Ethereum is a great way you can do that. They have a built-in architecture that you can leverage. So we see Ethereum being used in areas where that coin or token can provide some value to a solution. Things like fractional asset ownership, tracking customer rewards or loyalty points, building out gaming ecosystems. But by and large, Ethereum tends to be very consumer focused, and this is not a rule. This is not saying that you can't use Ethereum in B2B scenarios, but typically it tends to be the platform of choice for B2C or business to consumer scenarios. And because of the anonymous nature of Ethereum, this permissionless idea, there are a lot of folks right now focusing on how they can add identity management into something like Ethereum, so that Ethereum can become more of a hybrid and also do permissioning and identity management and role-based access, etc. I want to show you real quick a site called Etherscan.io. This is what's known as a blockchain explorer. You can come in and view any transaction that ever happened on Ethereum. You see these for just about every public blockchain, but we just happen to be looking at Ethereum. And I won't go into this in too much detail, but I did find one interesting transaction this morning. This one for a little, just about $250,000, $225,833. So what we can see, and this is public information, you guys can go to the same URL in a browser and pull up this exact same page. We can see that whoever this identity was, this account, this wallet, just transferred 465 Ether, or a little over $225,000 to whoever this account is. So all of this, again, is very public information. It's fully transparent, and it's okay that it's transparent because we provide anonymity to the participants. I don't know who this from is. I don't know who this to is. This may be someone on the call even. Who knows? All I can tell you is that this isn't my $225,000, or I would be flying to a beach right now. And I can also dig into any one of these accounts. So I can see that whoever sent this money has about $10.5 million sitting in their account. So things that you couldn't normally do in a traditional banking scenario, because Ethereum is designed to protect anonymity and to give people a high degree of anonymity, just like any other public blockchain. And that brings us to Hyperledger, which again is not a competitor. It's just a very, very different type of blockchain. Hyperledger is also sneaking up on its 3rd birthday. It was released at the end of 2015. So just an important thing to keep in mind as you're getting into this technology. All of this is less than 3 years old. It's still very, very new, which makes it very dynamic and fast-paced and a very exciting front to be a part of. But Hyperledger, just like Ethereum, is an open source project. It's managed by the Linux Foundation, the same group that's brought us lots of great solutions like Node.js and Linux itself. One of its biggest corporate backers is IBM. And again, just like Ethereum, there are a number of other corporate backers. Ethereum actually has over 220 different organizations that support it, but the biggest one is IBM. It is a private permissioned blockchain, so it's very different from Ethereum in that there's no anonymity. We have named users, right? Because if I want to be able to apply permissions and role-based access, well, the very first step to that is knowing who you are. And that permission model also means that there's no transparency, that not any anonymous user can get in and see any point of data they want like they can on Ethereum. So you will not find a Hyperledger Explorer like we just looked at on Etherscan. And so that means that Hyperledger tends to be very business focused. It tends to be used mostly in B2B solutions. Again, that's not to say that you couldn't use it in a business to consumer model, but because of where Hyperledger starts out and its focus, it tends to get used more in that world. Unlike Ethereum, there's no native coin or token. If you want to have a coin or a token, That's something that you have to build on your own. It certainly can be done, but if you need a coin or a token architecture right off the bat, you may want to look at Ethereum. And Hyperledger is really focused as a blockchain for business, or blockchain for the enterprise. So you see it used a lot in supply chain, value chain type solutions, in solutions where tracking the life cycle or the provenance of an item or good is important, less of consumer-focused solutions. So a quick comparison of the two, whereas Ethereum is anonymous, Hyperledger gives us named users. The fact that Ethereum is anonymous means that it's fully transparent and open to the public. I can't restrict access to anybody or treat any users differently if I don't know who they are. Versus Hyperledger, which is closed to the public. You have to be given access into Hyperledger, and it's permissioned. I can control who sees what, who's allowed to do what, who are the participants in each type of transaction. Ethereum is a single blockchain. It's a single ledger. That's why we can go out to a site like Etherscan and look at all the transactions that have ever taken place on Ethereum. Hyperledger takes a different approach. Hyperledger uses multiple blockchains or multiple ledgers. They're called channels in Hyperledger terminology. The idea here is that if all of us on this call are part of a giant business network, let's say that I'm Toyota Motor Company and you guys are all suppliers to my factories. Well, I don't want to have all my data living on just one ledger because I don't want everybody to be able to see the terms and agreements and prices paid in all those other business relationships. It's important that if you supply me with alloy wheels and someone else supplies me with engine blocks, you only see the ledger that contains information about our relationship to buy and consume alloy wheels. Because Ethereum is a public blockchain, it has an extremely large network size. There are over 16,000 active nodes on Ethereum right now. Because Hyperledger is a private blockchain, and organizations develop Hyperledger solutions to suit their needs. They're typically much, much smaller, and again, because they're not public, they're a lot smaller. In Ethereum, this large network size is what gives us security. Again, the only way to really hack or change the record in a blockchain, especially on the public side, is what's known as the 51% attack. So if I can somehow convince 51% or more, a majority of the nodes on the network, to go with my alternative version of the truth, well, then I've successfully pulled off a hack or a change. And that's very, very difficult to do in a network like Ethereum with 16,000 plus nodes, because that means I have to convince 8,001 or more. So the security in Ethereum comes from that large network size. The security in Hyperledger comes from our access control rules. Because I know who all my users are, they're named individuals, I can start to control who can see what, who can't see what. So once anonymity goes out of the picture, my security can be derived from the rules that I create around who can access what kind of data. On Ethereum, all nodes or miners are equal. In Hyperledger, we have different kinds of nodes. We have what's known as an endorser, a peer, and an orderer. And the idea that Hyperledger has is let's not ask all our network nodes to perform all the same functions. Let's let them specialize a little bit, because this makes it easier to scale and offers greater performance versus the simplicity that you get on Ethereum, just having all nodes existing in a true peer-to-peer fashion. I recommended on an earlier slide, hey, if you're just getting your feet wet in blockchain, especially the development side of it, you may want to start with Ethereum because it has that large, mature ecosystem. Another reason is that it's very simple compared to Hyperledger. Ethereum gives you a public blockchain platform to build solutions on top of, which means a lot of the decisions about the mechanics of how that blockchain platform works have been made by the Ethereum developers, and you can just really focus on creating your smart contracts and your solution on top of them. In a Hyperledger environment, you're making a lot more decisions about what that environment should look like, so it's a lot more complex. Ethereum tends to be a lot slower than Hyperledger, so solutions where you need outright performance, it may not be a good fit. Ethereum can also be relatively expensive in terms of transaction fees and the cost that you pay to cover the execution of your code. Whereas Hyperledger, because it's running on your own hardware or hosted hardware, it's an open source project to begin with, there's no licensing fees to pay, it's very, very low cost. In Ethereum, again, because folks are anonymous, the incentive, to be honest, is an economic one. We incent nodes to be honest and to try not to cheat the system, because if they do, we've set up a system in which all they're going to do is perform work that costs money with no chance of ever recouping any value for that work. In Hyperledger, because we know everyone at an individual level and we know who they're associated with and what roles they have and what processes they're responsible for, reputation is what keeps someone honest. If you have a Hyperledger network in a business environment and all users are known, well, that gives folks a pretty good incentive to behave properly because their jobs and their reputation are on the line. And then finally, Ethereum right now and public blockchains are getting all the attention. As you get into blockchain, you'll find that's where the majority of attention is right now, and Hyperledger is not getting the love that it should, but I really think that's where a lot of the growth and cool solutioning is going to be. So we're going to focus a little bit more on the private permissioned Hyperledger side of things, because if you're interested in Ethereum, there's already a lot of good information out there. So big difference between these two platforms is how transactions are recorded. On a public blockchain, again, all our users are anonymous, so we're going to have one or more anonymous users announce a transaction. And we see an example here that maybe Alice decides to pay Bob 2.5 Ether. And of course, what we see in parentheses there is we're not actually recording Alice and Bob. We don't know who they are. We're just recording the wallet ID or the account ID associated with each one of them. So we may see something like 12345 has decided to pay 98765 some money or some Ether. When this transaction is announced, it gets recorded by all nodes on the network. It gets recorded on the current block, and you can just think of a block as a sheet of paper. It's an area that holds a fixed amount of data or a fixed number of transactions. All these nodes are going to continue to record transactions on their sheet of paper until this block is all the way filled. And then once it's filled, all the nodes are going to get together, and they're going to compare what they have on their individual blocks or sheet of paper. And whatever version the majority have or the majority agree with is what we're going to consider to be the truth. We're going to cryptographically link that or chain it back to all previous blocks. And now we know that any data on this block or any one that came before it is all data that the network has agreed at a majority level is the right data. On a public blockchain, again, because it's permissionless and anonymous, anyone can see those transaction details versus a private blockchain, which works a lot differently. So in a private blockchain, we might have a vendor-supplier relationship. We might have Alice Johnson of Acme, and she's delivering parts to Bob's Motor Company. This transaction is going to be managed by a smart contract or chain code in Hyperledger terms. So what happens is when these wheels are delivered to Bob's Motor Company, and that smart contract gets executed, it is only being executed by the nodes that Acme and Bob's Motor Company are running. In other words, if there's another supplier, if there's Doug's engine shop, Doug and his employees or his hardware, his nodes, they're not a part of this transaction.
I don't think so.
And what's very different is that all the nodes participating have to agree on the result of the transaction before it's added to the blockchain. So different than a public blockchain in that consensus is reached among the relative or the participants involved in the transaction before it gets recorded to the blockchain. And so that means that in a private blockchain, we can look at any record on the ledger, and we can know that it only got added to the ledger because all the participants in that transaction already agreed the data was correct. The details of this transaction are only going to be visible to the participants who have access to it, who we've granted access to it, unlike a public blockchain. So it's a very, very different kind of animal. And important takeaway here is because each transaction that gets added onto this ledger has been agreed upon by all the participants before it even gets there, then there's no need for any further audit after that record gets added. There's no need to go back and reconcile to make sure that's the right data because we've agreed right up front, all as participants, that is the right data. So private blockchains give us some value, some benefits that public blockchains may or may not. The first is this idea of consensus. So again, all the participants in a business transaction agree that the outcome they got is correct before that transaction gets committed to the ledger. So we know that any information we see on the ledger is something that everyone's agreed on. It provides us provenance, so if we want to see the full history of an asset, how it was created, what happened throughout its life cycle, and when it finally ended its life cycle, we have that kind of information. Because all this is happening on blockchain, it's immutable, all our data is cryptographically linked. We can have a very, very high degree of trust that no one has come along and changed any data in the ledger because doing so is very, very difficult. It also gives us finality, which is one of the biggest benefits in a business scenario. Because private blockchains set up this shared infrastructure for all the participants in a business network, and because all those participants agree on the final state of any transaction that involves them, we by definition have a shared resource, a shared infrastructure, and all the records on it, all the participants agree are correct. So this gives us a single authoritative source of truth. We don't have to go back and audit or reconcile after the fact. We can simply trust the information that lives on our blockchain. And finally, it gives us privacy because we're operating in a permissioned model, and so we can determine who the participants are and what they can see. Some of the components of a private blockchain solution, a little bit more defined and nuanced than a public blockchain solution, right? We have the participants, who are the actors, who are the humans, who are the organizations that they work for that are participating in this business network. What are the assets? What are the things that those actors are interacting with? What are the properties and attributes of those assets, and what is the life cycle of an asset? Because an asset is not a permanent thing. It may be, it may not be, but a lot of assets have a fixed life cycle. They're created, they exist for a while, and then they're destroyed. And finally, we define our transactions, which talks about how do our participants interact with the assets, how do the properties and attributes of an asset get changed or updated, and the transactions, the records of how participants interact with assets are the piece that actually gets recorded on blockchain and stored as permanent records in a Hyperledger solution. So I want to walk you guys through a real simple demo of Hyperledger, a real simple sample solution. You guys can go out and play with this one yourself. There's a link in the slide deck to the Composer Playground. And when you first jump on the Composer Playground, there are a number of pre-canned solutions. So I just saw the question come up in chat. Can I share the link to the slide deck? Absolutely. If you didn't get it at the very end of this presentation, I can go ahead and paste it, and I'll just paste in another copy right now real quick. So if you didn't get the slide deck, you can download it using this link, and of course, like I said, I'll send it out at the very end again for anyone who missed it. But you go on Composer Playground, and one of the sample projects they have for you to play with is the car auction network. So in this car auction network, we have two different types of participants. We have the auctioneer and members. We're going to focus exclusively on members, not worry about the auctioneer. But some of the properties of a member is an email address and a balance that they have. We have two different types of assets. We have the vehicles that are being auctioned off, and the vehicle listing itself. The vehicle has a notable property, which is the owner, the participant that owns the vehicle. The vehicle listing has an interesting property, which is the reserve price. The vehicle is not going to be sold to anyone who bids under the reserve price. And finally, we have a couple different transactions that we can perform. We can make an offer on a vehicle that's being auctioned off. And then the auctioneer can come and close the bidding. It's time to end the auction. And when the auctioneer closes the bidding, if there has been a bid that was made above the reserve price, well, then ownership of that vehicle is going to get transferred to whoever made the highest bid that was above the reserve price. So let's jump into Composer Playground and look at this real quick. Here's our vehicle network. Again, you can unbox and play with this example yourself in Composer Playground. This is just an out-of-the-box example. But I've got a participant auctioneer. I've got a few different members. It's very easy for me to create a new participant or member if I want. You'll see that all this data that we're working with is just standard JSON formatted data. So I've got a couple different participants here, Bob, Charlie, and Dan. I've got a vehicle listed right now, VIN number 12345, and the current owner is Bob. And then I've got a vehicle listing where this vehicle is for sale. So I'm selling vehicle 12345, here's its state, a description, reserve price, etc. The definition of these participants, assets, and transactions is all defined behind the scenes. I have what's known as a model file, which defines my assets, transactions, and participants. So for example, I can see that here's how I define a vehicle. If I want to change how a vehicle is defined, maybe we want to add a property to track the color of a vehicle. It's very easy to do that. I can deploy those changes in the test environment with a click of a button. I have a script file, my logic.js file, and this is just standard JavaScript that defines how my transactions are executed. So if someone decides to close the bidding, the auctioneer, here's actually how we go through, look for the highest bid, make sure it meets the reserve price, and then transfer ownership of the vehicle. Here's the JavaScript code for how we actually make an offer, very, very simple code. And then I have my permissions or my ACL file. This is how I control access to all the participants and what kind of data they can see. And we can come back and see now if I try and create a new vehicle, you can see I now have color as a property just because I added that. And then I go ahead and perform transactions. So I say, let's go ahead and let's make an offer on a vehicle. So let's go ahead and let's bid $6,500 on listing, hang on, I forgot the listing number, listing 9876. And we'll say that Dan is the bidder on this. So let's go ahead and submit our bid. And now we can come and we can go ahead and close the bidding. So let's go ahead and stop bidding 9876. Well, I've done something wrong there. Wouldn't you know it, right when you're going to demo something, that's when it all goes wrong. So I won't sit here and try and troubleshoot this, but what we would have seen is, oh, we lost a vehicle, that's why. Let's say that our current owner is Bob. Now we should be able to, all right, well, I'm not going to worry too much about this, but if you play around with this and you don't change any of the model definitions behind the scenes, what you'd see is when you closed out that auction, the owner of that car has now been updated to the highest bidder. So just a real simple example that you can play with to get familiar with Hyperledger. I showed you all the different components, the model file, the JavaScript logic, the permissions ACL file. And then once you've defined what your solution looks like in Hyperledger Composer, you can easily export that solution. There's a real quick export function as we're defining everything. You can then import what you've built into your own Hyperledger environment. And once you get it over there, Hyperledger is kind enough to build a fully functional REST API around your solution for you. So you can turn your developers against this. It's going to be very, very familiar for any web developers. They're just building a solution against a REST API. They don't have to know anything about Hyperledger or how this was built. So very, very easy learning curve organizationally. There aren't a lot of new skills that need to be picked up. If you have folks that are familiar with and comfortable in JavaScript, well, they're going to be able to jump into Hyperledger right away and start building really, really cool solutions. So areas where we see Hyperledger being used, manufacturing. If I'm an automaker and I can track everything that happens to one of my vehicles, from the time it first rolls off the factory floor to the time it goes to the crusher. Well, that's some real valuable information. Maybe I can start competing with Carfax and taking some of their business away. Mercedes-Benz is looking at this ways that they can provide better information about their vehicles than someone like Carfax, and they can monetize that information. Any kind of supply chain solutions, we see Hyperledger being used a lot. So any kind of food supply chain, food recalls where there's just a lot of waste when we do recalls is an interesting area. Auctions and online marketplaces like we just looked at. Advertising and media sales tend to have very, very complex contracts, need a lot of auditing and third-party involvement. Same thing with cable television, complex industries like aviation and aerospace where you have tremendously large business networks with a lot of participants. Interest in Hyperledger and blockchain in general, inventory management, banking, e-commerce, etc. So a lot of different areas that folks are looking at this technology and trying to apply it to. How you might spot some potential use cases in your world or your business. Hang on, I'm just going to go back and mute everyone because we are getting some feedback. All right. How you might spot some use cases in your business. We'll look for areas or areas where there's large business networks. There are a large number of participants in a business process. That can be a great area for blockchain and Hyperledger. Anywhere where you have swivel chair integrations between systems, so one person entering data and then swivel a chair around and enter that same data in a different system. It's a very error-prone way of doing things. Any business processes where you have to have third-party audits come in and reconcile your data. Any solutions or areas in your business where there isn't one single authoritative source of truth, and this kind of relates to the auditing idea. In a business network, I keep my records, you keep your records, and we have to bring in a third-party auditor to review both our records because there's no single source of truth between us. You have your truth, I have mine. We don't have one that we share. So any areas in your organization where there's no single source of truth, or where you know that it's just a very inefficient process and it could be done a lot better, that can be a real great fit for Hyperledger. If you have lots of geographical or time zone separations where it makes it tough for folks to interact and collaborate together, well, offloading some of that work to a blockchain solution can be a really good fit. If you have areas in your business you're trying to address because you have a lot of inconsistency in how a process is being performed, blockchain and smart contracts can really help address that and ensure that every time you execute this business process, you're doing it consistently. And then finally, any areas in your business where you have low or zero value add. I like to pick on payroll. It's an essential function of any business. You have to pay the employees if you want to stay in business. But unless you're focused on providing payroll services, it's a zero value add. It's something you have to do, but most businesses aren't in business to process payroll. They're in business to do something else. So you can start to offload some of that low value add or zero value add process management onto blockchain and onto Hyperledger. Those can be really, really good solutions too. So if you're interested in all this, you kind of enjoy what you've heard and you want to know where to go from here, well, there's a couple areas you can take a look at. First of all, I'm always available if you want to talk about this, want to learn more about the training that we offer, or how blockchain might fit into your business, or some help identifying and solutioning different use cases. So you can always shoot me an email, kbennett@Blockchain Training Alliance. There's also a really, really good blockchain community building up on LinkedIn, and I'm a little biased towards LinkedIn because unlike a lot of other blockchain communities online, other ones tend to be very technically focused. They tend to have a very large developing and engineering audience. LinkedIn is a very, very good resource because it has a very diverse audience, people from lots of different professional backgrounds, not just technically minded folks. So a lot of good organic discussions that happen there. If you want training and certification, obviously I'm very biased here, but check out Blockchain Training Alliance. We do offer certificate-backed training in blockchain architecture, development, security, etc. If you want to jump in and learn Hyperledger on your own, do some self-studying, the Hyperledger Foundation has a wealth of great resources out there. It's really a shame that these resources don't get promoted more because they've created some great material, made the platform very accessible, but a couple good learning solutions there. You can use those links. And then finally, if you actually want to get hands-on with Hyperledger Composer, get into this test environment that we demoed, well, that's just the Composer playground. You can use the link there, sign up and use some of the out-of-the-box examples they have, and also start extending them to build your own solutions. So thanks, everyone, for joining. I know we're a few minutes over 9, so I appreciate everyone sticking around. I'm going to go through and see if we have any good questions that popped up in chat, and I'll answer some of those. But like I said, feel free to download the slide deck. I'm going to go ahead and paste the link one more time in chat. And the slide deck is going to have all these links, my email in it. So please reach out. Let me know any questions that you have. And hopefully this has got you excited and a little bit more knowledgeable about the difference between public and private blockchains and about how private blockchains might be used in your business. So let's see if we have any really good questions here. Let's see, can we say Ethereum is public and Hyperledger is private? Yes, absolutely. Again, Ethereum is anonymous, it's publicly accessible. All the data on Ethereum is fully transparent. And in Hyperledger, by default, nobody has access until you grant it to them. So yeah, definitely the correct perception there. Ethereum is public open, Hyperledger is private closed. Are there any good books on blockchain? I get asked this one a lot. There are lots of good reading materials. Book formats themselves tend not to be that popular in blockchain. The reason is pretty simple. This is a space that is very new and it's moving extremely quickly, and things are changing all the time. So because of how fast things change, there aren't a lot of books on blockchain, because by the time a book makes it through a traditional publishing process, there's a good chance the information is out of date. So you will find some good books about just general blockchain principles and tokenomics, but I would encourage you, if you really want relevant information, look at the foundation that supports each platform. So if you're interested in Ethereum, the Ethereum Foundation has some of the best documentation. If you're interested in Hyperledger, the documentation that the Linux Foundation puts out is some of the best. I'm also pretty intellectually lazy myself, just personally, so I love YouTube, because if I can watch a 5-minute YouTube video and get the same information that I would have gotten from reading 50 pages, that to me just seems like a win. So there's some really, really great YouTube channels. I would encourage you to poke around on there. There's one called Ivan on Tech. I just posted this in the chat window. But if you're just interested in general blockchain, not any platform specific, but just kind of general blockchain topics, the Ivan on Tech channel on YouTube is a really, really great channel. Ivan's a very knowledgeable guy, comes from a development background, but doesn't explain things in an overly complex or technical way. Let's see. So there's a question here on the Solutions Architect exam. I'm not sure how well the study guide or the book relates to the exam. So the study guide, if you are taking the exam, was designed to show you all the areas that you might want to go and self-study. So we did make sure that we covered or mentioned every area in the study guide that is going to be covered in the exam. That doesn't mean that all the answers are there, but it's just giving you a list and a start to all the topics you need to go out and self-study on your own. And if you have any questions on that, on the exam or the study guide, just shoot me an email. Let's see, interest in learning about insurance-related projects. So there are a lot of folks in the insurance industry who are interested in using blockchain. A lot of claims validation and claims adjustment solutions are being built on blockchain. So a lot of information around insurance. If you want to chat more about some of how the insurance industry is using blockchain, I'd love to have that chat with you, Raul, and I see your email address. So I will shoot you an email. We'll schedule a time we can talk about this a little bit more, but yeah, definitely some good use cases around insurance. And again, any of you guys who want to have further conversations about blockchain and how it might fit into your organization, definitely feel free to shoot me an email. Let's see, what do you think are the different principles of designing a blockchain solution for an industry? So this is kind of a big question. We spend 3 days talking about this in the blockchain architecture course. There are a lot of different principles that you want to look at. I would say if you take anything away from today's presentation, start going in your organization or in the world around you and start looking for some of these big red flags, because these are going to be great ways that you can spot good use cases for blockchain. So again, large business networks, large numbers of participants, human integrations to different line of business systems, areas where we're always or regularly having to go back and audit and reconcile. We take that out of the picture with a private blockchain because we know anything that gets added to the ledger as data we've already agreed is the truth. Areas in the business where folks get frustrated because they know it's inefficient, they know there's a better way, or just areas that are screaming for blockchain. And any of those low value add or zero value add processes are great ones to start offloading to blockchain. So I would say that these are some of the first areas you'd want to look at around you. Hey, what meets all or some of these criteria? Because those are going to be some of the most interesting ones to start exploring with blockchain. As far as the principles of design go, really that's just learning a lot more about the different platforms and tool sets and what they provide, and then starting to understand or answer questions like, hey, am I building something public or private, open or closed? Where does my solution fit in this kind of decision matrix that we see on the screen? Let's see, with respect to Composer, all the code is written in JavaScript for smart contracts and then translated into Golang, or is that a lower level language? All those smart contracts get compiled down into bytecode. So you can certainly use Golang if you want. You don't have to use JavaScript. It's another option, but JavaScript is definitely the most popular one. Let's see, I know we concentrated on Ethereum and Hyperledger. Can you tell us how Corda compares? I know that Blockchain Training Alliance is working on a course for this. Great question, Brian. Thanks for asking that one. Yeah, we didn't talk too much about Corda. Corda is a solution created by an organization called R2. It is much more similar to Hyperledger than it is to Ethereum. So just like Hyperledger, it's a private blockchain. It is permissioned. The consensus mechanism operates very similarly to how it does in Hyperledger, and the consensus is reached before a transaction is added to the blockchain. We're dealing with named individuals, so we use reputation as the driver towards honest behavior rather than any kind of economic incentive. And there's no built-in coin or token, just like Hyperledger. The real difference between Corda and Hyperledger is that Hyperledger is focused on being a very, very general tool, so you can use Hyperledger and the tool sets behind it to go build any and every kind of solution. Corda has a very, very narrow focus on just banking and financial solutions. So Corda really gives you a better starting point if you want to build a solution for the banking and financial services industry. It's got a lot of those logic and workflows already baked into it, where Hyperledger doesn't. They are two distinct products or offerings right now, but there's a lot of discussion in the Hyperledger community about officially bringing Corda in under the Hyperledger umbrella and managing it through the Linux Foundation like the rest of the platform, and actually making it just a derivation or a cousin to Hyperledger. So they're very, very similar. It's really just the focus that's different. So great questions, everyone. Any other questions that we have? I'm open to stick around for a few more minutes if there are. If not, we had really, really great turnout today. I appreciate all you guys making time on a Friday morning to listen to me chat about blockchain. Had a really good turnout, so I think we'll definitely be doing more of these. Let's see. Oh, here's a great question. Can you make Ethereum private? Yes, you absolutely can. Absolutely. Ethereum, just like Hyperledger, is an open source project. So you can always go and take the source code and use it to set up your own private Ethereum instance. You can even pull down that source code, and if you don't like the way Ethereum behaves or handles certain things, you can create a fork of that code base and put whatever information you want into it. And then set up your own private Ethereum instance. So you absolutely can make Ethereum private. There are also a number of different hosting providers that offer private Ethereum instances. So Microsoft has an offering through Azure for a private Ethereum blockchain. I believe Amazon has or is working on one. So you absolutely can set up your own private Ethereum networks. Let's see, when can we have the next session? Stay tuned, follow Blockchain Training Alliance. We're on LinkedIn. We'll be sure to share information there about the next one. We'll also start posting a schedule of these webinars on our website, so you can keep track there too. I think it's a great way to get some of this blockchain information out into the public, and I really enjoy doing these kind of things. So definitely stay tuned. We'll have some more. Let's see, Diane asked me, can I talk a little bit about MDM, master data management, as a use case? A lot of possibilities there in terms of MDM, a lot of things you can do. A lot of folks already pursuing use cases around MDM. I think Diane, reach out to me, shoot me an email. Let's have a little bit more detailed conversation about maybe what you're thinking and how you would see it applying and some of the problems you're trying to solve, because that is a very, very big area. And there are lots of folks taking lots of different views on how blockchain can be used to address that. One of the things you'll find with blockchain is even if you look at one particular use case, for example, consumer banking is a great example. You might look at a consumer banking solution, one particular use case, but two different organizations, different size, different cultures, different goals, would pursue radically different architectures and solutions to it. One might choose a private blockchain, one might choose a public blockchain, one might opt for purely conventional technology and not bring blockchain into it at all. So MDM is kind of one of those areas like consumer banking where really it just depends. So I would love to chat with you a little bit. Shoot me an email. Let's find a good time to talk and tell me a little bit more in detail what you're thinking, and we can spitball some ideas. All right. Well, hey, thanks again to everyone for joining this morning. Just in the interest of redundancy, I'm going to paste the download link for this slide deck one more time for anyone who didn't get it. Please go download a copy. Feel free to use this to share any blockchain ideas or as a starting point for your own slide deck. Good artists create, great artists steal. So go out and be great artists. Appreciate you guys showing up. Hope I get to see you on the next webinar. And like I said, feel free to reach out. We can chat a little bit more about blockchain and how it might fit. And hopefully you guys learned something. And if you didn't, hopefully the rest of your Friday goes better than this. But thank you, everyone. Have a great Friday. Have a great weekend. And we'll see you next time.